So, in part two of this series, we will be going over creating a simple boost pedal, and we'll learn how to measure that circuit's gain. We'll learn how to create a potentiometer on it so that we can adjust this gain and show the gain sweep over the turn of that potentiometer knob. Before we begin, I just want to mention that LTSpice is a simulator, so depending on what it is able to simulate, LTSpice might miss specific details that might be important to you. LTSpice is a very strong tool to have in your toolbox of design, but as such, it's not meant to be a replacement for your ears. So, with that out of the way, let's begin. Alright, so the first thing we're going to do is we're going to go to File and go to New Schematic. We're going to create two voltage supplies. One's going to simulate our guitar input signal, and the other one's actually going to be the supply that powers the pedal. So I'm going to click on the Components tool here. I'm going to go over to Voltage. I'm going to drop one here, and I'm going to drop a second one here. Hit Escape to get out of it. I'm going to create a ground for these, so click on the ground tool, place them underneath your supplies, hit Escape to get out of that. Then using the wire tool, we're going to wire in the grounds. Just click left click on the part you want to start, and then left click again to end. And then hit Escape to get out of the wire tool. So for this one that I labeled V2, we're going to make this the 9-volt battery supply. So right click on that, set that to 9, and press OK. And this one we're going to set, we're going to right click on it. I'm going to go to Advanced. I'm going to set this to Sine. I'm going to set the amplitude voltage to 0.132, which is a decent simulation voltage for a really hard hit single string on average output capacitors, average output pickups. We're going to set the frequency to 1K, 1 kilohertz, and then we're going to hit OK. Next thing we're going to do is we're going to create another wire here that comes out of the top of V1, and then hit Escape, and I'm going to do similarly with the tip of V2 here. Oops. Wire, and hit Escape. Next thing I'm going to do is I'm going to press F4 to bring up the labeling net name section here. I'm going to call this plus 9 capital V volts. And this will allow me to label this wire 9 volts by putting the square box on the tip of the wire. You'll know that it worked because it'll flip the thing 90 degrees like that. I'm going to do that again over here, and I'm going to call this one input. Attach that to the tip of this. Next thing we're going to do is we're going to create the basic power supply that I start with in a lot of cases. So we're going to create a diode first for reverse polarity protection. Click on the diode tool, hit Control R once, and then Control R again to rotate it where the cathode is facing up, and click where you want it to be. Hit Escape. If you right click on the diode itself, you can then select Pick New Diode and select the 1N4001. Let's give it a ground, so click on the ground tool, hit Escape, and then we'll wire in the ground. Hit Escape. Next thing we're going to do is put in our bulk capacitor, so click on the capacitor tool, drop that here, hit Escape, right click on it, set the capacitance to 100 U for microfarad, hit OK. I'm going to right click on it again, and then click on Select Capacitor, and then scroll all the way down. I'm usually looking for voltages at around 16 to 25 volts, because that's typically what I'm using in my guitar pedals. And then I'm going to go here to Electrolytic Nichicon. Let's grab one that's actually 25 volts though. There we are. And then give it a ground. Escape, and then wire in the ground, and Escape. Now the next thing I'm going to do is I'm going to create a voltage divider. So I'm going to take a resistor here, click on resistor, put that here on the screen, and then I'm going to put another one underneath it, and hit Escape. I'm going to set these both to 100K by right-clicking and setting the resistance to 100K, hit OK, and 100K on that as well. And then we're going to click on the ground tool, put that here, and then let's wire in the ground. Lastly, I'm going to put in a bias decoupling capacitor, so click capacitor here, put that right here, right click, set that to 47U for 47 microfarad, then right click on it again, select capacitor, looking again for that 25 volt electrolytic. Technically, yes, I know this one could probably be less because it's going to be like 4.5 volts, but we'll use it anyways. Hit the ground tool, and set that to ground. And then we'll wire these all together here. Hit escape to get out of that. And the wiring tool again. And you'll notice that I put these two little spokes right here. That's so that I can put labels on them. So now I'm going to press F4. And I'm going to put in a label of +9 capital V, just like we did over here with the power supply. And put that right there. This now makes it so that, press escape. This makes it so that this power supply is now attached to this part of the schematic. Otherwise, I'd actually have to draw wires to everything, which in something small like this probably is not a big deal. However, as your schematic gets more complicated, you'll thank yourself to do this. Press F4 again, and we're going to create one here called V-bias. And we'll put that right there. All right, we now have a power supply. Let's actually build the rest of the pedal. So I'm going to click on the wire tool over here, and I'm just going to start right over here somewhere. Hit escape, hit F4, call this input, and put that right there. These do have to match so that they know that it's one and the same. Hit escape. First thing I'm going to do is create a pull down resistor to this, or a bleeder resistor for the anti-pop. So put that right there. We'll set the resistance to 10 meg. And then we'll give it ground. And then we'll wire it all in. Next, we'll create a coupling input capacitor. So click on the capacitor tool, hit Control R to rotate it 90 degrees, and we'll put it right here. And then we will right click on it and set it to 100 nanofarad. So 100N, and press OK. We'll click the wire tool again and wire it in. Now we need to set a bias resistor to pull up to. So we'll put a resistor right here, hit escape, right click on that. We'll set this also to 10 meg. And we'll wire that in. We'll put a little wire on the top here and press F4 and set that to V bias. Press enter and make sure that it lands tip like that. So now we have a bias resistor going in. Let's put in a current limiting resistor here, so Control R to rotate it. Something small, we'll just make it 1K. So we'll right click on that, set to 1K. Wire that in. Escape. Now we're going to add our op amp that we've probably set up from the last video. So let's go to Component. And this is where we'll scroll all the way over to Auto Generated. And we'll select the TLO71. So in here we will use this op amp. Put it right there. So the first thing we need to do is put our input by wiring it into the non-inverting input of the op amp. Hit escape. Let's give that op amp ground by wiring that in. And then let's give it power by giving it a little wire right there, pressing F4 and putting in +9 volts. Now that's got power. Perfect. Next thing we're going to do is we're going to put in a real small ceramic capacitor in our feedback loop. So we're going to hit that and Control R to rotate 90 degrees. Put that right about here. Escape. Right click, and we'll type in 47P for 47 picofarad. And then we will wire in that feedback loop. All right. Now we'll put in our resistors that will set the gain. So Control R to rotate it. We'll put that right up here. We'll set this guy to 56K. And then we'll wire that in. Escape. And then I'm going to create another resistor here. Control R. Set that here. Escape. Set this to 50K. We'll wire that in. I'm going to set in another resistor, so Control R to rotate it. And we'll set this to something small like 2.7K. Let's create a capacitor here. Control R. Escape. We'll set this to 4.7U. Right click on that and go to Select Capacitor and then select an electrolytic here at 25 volts. Go. And wire these all in. Let's create a ground. That right there. Wire it in. All right. Now we need to set our output here. So let's escape and put an output coupling capacitor. Control R to rotate it. And we'll set this to 470 nanofarad. Wire that in. Escape. Let's put in a current limiting resistor here for our output impedance. Escape. Set this to 470 ohms. Wire that in. And this isn't going to have a volume knob, but if it did, it would be a 10K volume pot. So we're going to set a resistor here to pull down to ground and set that to 10K. Put in our ground. And then wire all that in. A little extra right there. Hit escape. Press F4, and we'll create a section here calling it output. And then put that on the tip. So now we have a complete pedal right here. We have a power supply. We have an input guitar signal. We have our actual circuit. But we have nothing variable. This is basically just a hard circuit, so a stomp box with no knobs at this moment. But it does do something, so let's take a look. If we go to Simulate, and we go to Edit Simulation Command, and we type in under the Transient tab for stop time 10 milliseconds, and press OK, it's going to want us to put this somewhere on here. Doesn't matter really where you put it. We'll put it right there. We'll go back to view, go to zoom to fit so we see the whole thing here. And then let's go to simulate and run. So right now we have a blank screen for our simulation. What it wants us to do is probe things. So if we click on something like our 9-volt power supply, right there, it's obviously 9 volts. Awesome. If you wanted to know what your bias was, clicked on that, you can see, hey, look, the bias is 4.5 volts. Notice that it actually keeps these labels on top here, indicating what is what. And you can actually have multiple things set up on here. But if you double click on something, it'll clear whatever is on the screen and only show what you last clicked on. So if I double click there again, I only see the 9-volt rail. But let's look at something a little bit more interesting than flat voltages. Let's go to our input and click on that, or double click on that. Here is our input guitar signal. It's a 132 millivolt peak-to-peak signal that we set down here with that voltage supply for the input. And because we are measuring a 10 millisecond span of time, and we are going at 1 kilohertz per the sine wave, we're getting a signal 1 time per millisecond, as we would expect. But let's take a look what we have on the output. If we click on this, you can see that the output signal is identical, except for it has been boosted by a decent amount. We can change this by changing the resistor value of R7. If we were to go in here and right-click on R7 and change it to something even smaller, such as 10K, and then tell it to run the simulation again, you can see that it boosts a lot more. Conversely, if you right-click on that and you set it to something much less, like 250K, and press OK, and simulate that, you'll see that the boost isn't much in difference. Actually, kind of just a smidge. If you want to see what the differences are, if you click on the blue V input, you'll be on the input sine wave, and using your left and right arrow keys, you can run that wave. And as I'm moving left and right, you can see in the timeline, oops, again, you can see in the timeline here that what my voltage is. So right here, that's my 132 millivolts peak to peak. And then if I click on, or X out of this thing right here, and then click on the output, I can do the same thing and see what the green or boosted signal is doing. So where my input was at 132, I'm now at 151.8 millivolts. So a little bit of a boost right there. So this is a way we can analyze the boost that's actually coming out of this. Now, because we're having to go in here and constantly change this value for R7, it would be nice if this was actually a potentiometer. So what we can do here is set this up as a variable. How do we do that? If we right mouse button click on R7 and set the resistance to left parentheses and then all lowercase pot1, pot1, and then right parentheses, we've now set this as a variable called pot1. So then I'm going to hit OK. And now what I'm going to do is I'm going to close out of this simulator and then maximize this back out. And back in my drawing here, I'm going to click on Spice Directive, or where it says .op. And then in this box right here, I'm going to type in .step space param space pot1 space 1 space 500K space 1K. So what I'm saying in this little command right here is I want to do a sweep of the param potentiometer. So I'm going telling it to step through this parameter, pot1, which is what we called this guy up here. If we called it pot2, we'd call this pot2. If we called it Batman, we'd call it Batman. And then the next part right here where we say 1, that's indicating where we're going to start. And then the next number here, 500K, is the maximum value. And in this case, we're going to assume that this is a 500K potentiometer. And then we're going to say we're going to step this for every 1K on the potentiometer. Now, if I do this, that means we're going to step through this thing 500 times, and that might be a little bit processing to handle here. So I'm going to actually change this last part to 10K instead. And now it's going to process only 50 times, stepping every 10K. So let's hit OK. And then it's going to want you to drop that somewhere. I'll just put it right here. And now let's go to simulate and hit run. Now you can watch here on the lower right hand side, this little run bar, that's kind of indicating all the calculations being done. So now, if I click on the input, we see our regular 132 millivolt peak to peak wave, which is good. That's what we wanted to see. However, if I click on the output right here, you now see multiple waves, some very, very large and some very, very small, but these are the sweep values that you would see from that potentiometer for boosting. So obviously as the pot is, closer to 0, we're getting a low boost. And then as the pot is coming up to max, especially when it is at max, we got this massive boost right here. But one thing you also notice too when looking at this sine wave is this is a clean boost. There's no flattening of the top of this curve right here. So there's no clipping of the rails, as they say. Well, what would that look like? Well, remember, I'm using a sine wave of 132 millivolts, which is like a very hard single string hit on moderate pickups. But let's do something that's more like a power chord on active high gain pickups. So let's right click on this and let's set the amplitude to 0.5 volts. So 500 millivolts, a half a volt peak to peak. Or actually, it's a half a volt, which would be, half a volt and a negative half volt. Let's go to simulate. And it's going to do its thing here again. But now what you see is we have that input signal, but with the boost, we notice that the very last value of boosting is now clipping and creating a little bit of a square wave as opposed to a curved sine wave. So that's maybe an indication that maybe we're giving this thing too much gain. Maybe we need to reduce this down to a lower potentiometer value. Maybe we need to change the value of R8 so that it doesn't let it get down to such a low value. Let's do that. So let's change R8 to something like 50K and then hit OK. If I go to simulate again, now I don't have any of this clipping issue going on. But that might be too low. I want to maximize that gain, so maybe we bunch this guy back up to, let's try going somewhere in the middle, like 10K, and rerunning the simulation. And once it completes, there we go. I have a little bit of clipping at 10K. Maybe I can live with that, maybe not. but this is where you can find out what values you need to accommodate the pedal you're trying to make in this case, which would be a clean boost. So this is the end of this tutorial right here. In the next one, we're going to go over gauging things like how to measure input impedance and output impedance, and adding a few more components to this thing, such as clipping diodes, to see how that affects the waveform. So that's it for now. If you like these kind of videos, press that like button, and if you haven't subscribed, please subscribe. If you want to support the channel, please visit our website, which is www.diyguitarpedals.com.au, and check out some of our kits that we have over there and PCBs that we have for our various projects. That'll really help us out. If you'd like to see more of this stuff, also, don't be afraid to put stuff in the comments indicating that you like this kind of stuff or you hate this kind of stuff. Or if you have any questions, don't be afraid to ask down there. If we don't get to you, someone probably will. Anyways, that's all for now, and we'll see you in the next video. Cheers.